International Space Station has been in Earth orbit for 25 years, shows humans' exceptional achievements in space exploration. NASA has invested over $400 million. Start developing a new generation of the International Space Station, the 2.0 project. But our exploration ambitions, it should not be limited to Earth's orbit. To go deep into space, we need to develop entirely new technologies, such as habitable mini-planets or other megastructures, maybe even in the hemisphere near the Sun. Deploy a megastructure to determine the future of our solar system. Imagine that, if we could build a giant generator from a tamer, extracting endless energy from a black hole. What a magnificent achievement this will be. These magnificent space structure projects not only are the technical challenges immense, and for humans, offer unprecedented opportunities for exploration. In this video, I will explore: build like death? Are space giants like stars really worth it? Why reshape the Earth itself? Probably not a good idea. NASA, working with private companies, NORs and villagers, space cooperation, committed to this ambitious goal. They plan to take private Starlab in 2027. Space station launched into orbit. This will be more than just a research laboratory. It will also become a center for space tourism. This space station, it will be equipped with a 340 cubic meter habitat module. Although this is 3 times smaller than the internal volume of the SS. But he solved the problem facing the International Space Station. Many questions. Starlab's habitat module features an inflatable design, composed of multiple layers of patented material. These materials help protect the space station from the universe, radiation damage, and gas leakage. It is worth noting that this is a private project. This is related to the government-led International Space Station is unlike any other. However, International Space Station, now there's the challenge of technical glitches. He got America, Japan, European countries, technical expertise in countries such as Canada and Russia. Every participating space agency is responsible for the feasibility of your own module, periodic inspections and maintenance. To extend the service life of the module, JSC and CSC plan to run their modules until 2028, and the Russian space module is responsible for keeping the International Space Station in orbit, prevent it from falling to the Earth. But by 2024, the International Space Station is likely to need to be moved ahead of schedule. Although Starlab is small in scale, but he couldn't solve it. One of the major challenges facing the International Space Station, prolonged exposure to a weightless environment, effects on the human body. Weightlessness not only inconveniences astronauts, it also increases health risks. Long-term weightlessness can lead to astronauts rapid loss of calcium, decreased bone mineral density, increased risk of fractures. Space agencies around the world are studying zero gravity short, long-term and long-term effects. But so these are not encouraging results. If we could build one space station with artificial gravity, then long-term space missions will become possible. We will be able to send astronauts sent to any corner of the solar system. However, creating artificial gravity is not consciousness. One of the great challenges facing humanity, how to build a class, a planetary-like space station, or even a mini-planet. To achieve this goal, we have two possible approaches. The first is to simulate natural processes, from a circular astrolabe to a similar, a mini copy of the natural ball formation process. The second is about building a planetary space station, like our own version of the Death Star. Take the Death Star. Suppose its diameter is about 140 kilometers. If made of steel, it's going to be an astounding 100 billion tons. Although this number is only 10 million of the mass of the Earth. But built like this huge structure, it's still a technology and huge resource challenges. For example, building a 1 million-ton Dubai Burj Khalifa takes time. 10,000 workers were employed in 3 years. Therefore, build a megastructure like the Death Star, in comparison, may be more complex and time-consuming. British Star Tour magazine aerospace engineer Mark Hamill pointed out that to create a mature planet, we need 1110, the mass of the Earth. If we will 700 warp tons of material, compressed into a ball the size of the moon. In the body, we can experience similar experiences on it. Earth's gravity, but how to achieve this compression is a huge challenge. One possible solution is to harness solar energy. By deploying and sidelining reactors near the sun, we might be able to generate the heavy elements required to build the Earth. Such a reaction buildup collects green from the surface of the sun, and it is used to produce elements such as geese and bovine. These elements are heated to 5,100 degrees Celsius. Will be launched to a specific location in the solar system. By colliding and combining, eventually form the core of the planet. When these elements cool to 1,600 degrees Celsius, they can be covered with layers of silicon, and it forms a kind of crustal structure. However, to create enough silicon and other materials, building an artificial crust, it requires a lot of resources. For example, the amount of steel required to build the Death Star reached 100 billion tons. The current annual output on Earth, the amount of steel is only 2 billion tons. To avoid spending 800,000 years to extract these resources, we must find other sources of silicon core metals. The objects in the asteroid belt, such as the asteroid belt, one of the largest celestial bodies, own up to $10,000 catties worth of Ni River iron reserves. These resources should be sufficient to build a Ranger Death Star. In addition, celestial bodies such as rocky asteroids could become man-made sources of materials for planetary crust. But in order to extract these resources, we need new models suitable for working in low-gravity environments, technology and equipment. Although these efforts may seem daunting, but building artificial planets, it is expected to solve the main problems facing the space station. Lack of gravity, for example. For structures like dead hearts, its construction must be consistent with. In the movie, the hearts of the dead compete. NASA, Aaron Stelzner, an engineer at the Jet Propulsion Laboratory, thought to be inside the space station, generates Earth-like gravity. You can place it on a sphere track rocket to achieve. And these rockets are going to rotate this structure around its axis, generates gravity internally with the help of centrifugal force. In addition, since there is no friction in space, rockets don't need to work continuously. The internal structure of such a space station will be similar to onions. The layers will be stacked. Technically speaking, the plane near the center of the sphere will experience gravity much lower than the outer shell. However, a major drawback of this structure is its instability. Stelzner thinks, to maintain stability, like the crew, must be constantly monitored, exact orbital parameters of the space station, and make adjustments. In exploring the concept of an artificial planet, build a building for the scientific complex seems like a relatively easy character, because in such a structure, stability and gravity issues can be effectively resolved. However, one of the main challenges is time. Even though we built a nucleus near the sun, variable reactor, and found enough return tectonic crust, build one from scratch, planets could take at least 10,000 years. This is clearly beyond the realm of science fiction. Enter a long-awaited reality. At this point, we might as well consider some scientists and science fiction. The even crazier megastructures the writers envisioned. American architect Buckminster Fuller, in the mid-1950s, proposed Keo. Item 9. This is a sphere about 1 kilometer in diameter, floating in the atmosphere like a hot air balloon. Fuller calculated that, to make this structure float, the air inside the sphere is only hotter than the outside, 1 degree Celsius higher. This structure can accommodate hundreds of residents. They can pass. The windows offer a constantly changing view. However, apply this structure to clouds on Venus. Colonial project, but it's challenging. Venus' acidic atmosphere and strong winds make this idea. It's almost like a one-way ticket to hell. And on Earth, such a structure could also have been encountered in the 20th century. A similar fate for airships in the 1970s. Physics plus Gerard O'Neill. They came up with a different idea. O'Neill original main body. This structure is only 500 meters in diameter, but can accommodate 10,000 residents. By rotating at a rate of 2 revolutions per minute, the cylinder generates artificial gravity inside it. The environment in which people live can include forests, rivers, and farms, building a perfect new world. However, even with such a structure, that sounds better than terraforming Mars. They face serious challenges, such as cosmic rays. Due to the lack of protection from the Earth's atmosphere, residents on a cylinder may receive a lethal dose of radiation. In addition, the impact of a meteor is enough to destroy this giant. The structure becomes a giant tomb. On a larger scale, some of them don't even think about safety. For example, Gulb's Kosses by Swiss architect Christian Volgogo project proposal almost turned the Earth upside down. Put it, everything is smeared on a giant sphere. This super project covers everything from building, space elevator to Jondaman, and the process of transporting the Earth into orbit. In this structure, gravity will shift from the Earth's core to the rotating crust, just like the original O'Neill cylinder. Although such a project is theoretically possible, but actually, we have huge fundamental challenges ahead of us. Imagine that. A tower 1,000 kilometers long. The heavy aircraft crashed to the ground. It could destroy the entire city. We can't help but imagine. A day at the Gilbis Cassis construction site. What will it be like? However, even this ambitious project, with Don Alderson's huge habitable disk box, compare also written fragrance architecture. In the mid-1970s, come up with this idea, almost like making a joke about a flat Earth, because the diameter of Alderson's disk, more than 240 million km, extending beyond the orbit of Mars. Its orbital thickness reaches 5,000 kilometers. Actually, the habitable zone of the disk is limited to the middle strip. Narrow band, but according to Alderson's design, the size of this area will be the ground, 50 million times the size of the ball. It could hold trillions of people, but there are always some details that need attention. For example, since the sun is always on the same side, the Alderson disk will always be in a state of perpetual. In Heng's eyes, it would be very difficult to walk on such a flat surface, because people are always pulled aside. We may need to invite a goat to teach us how to climb in this environment. However, these inconveniences may not last long. Due to the action of gravity, anything strange. The final shape of the object, it will become a rule. Sphere, Alderson's disk will exceed the mass of the sun. These objects eventually, it may merge to form a new bright star. Its residence will also be its fuel. In our solar system, the sun revolves around the Milky Way and rotates. We seem to be sitting in a square car. In the racing car of the disk, Soviet engineering lost. Onidorf in the late 1980s proposed a way to guide the solar system. A curved mirror 300 million kilometers in diameter. The stellar engine. According to the calculation, this engine could be ready in 200 million years. Move our solar system 80 light years. It would be the greatest engineering triumph in human history. American physicist Matt Cabrin, also interested in this idea, he recently developed a smaller device, only a few kilometers in size. He collected the Qinghai River Sea from the sun and burned them in the Johol reactor. Cabrin thrusters will move the solar system, accelerate to over 30 kilometers per second, and cover 50 light years in 1 million. But this thruster also has its weaknesses, such as electromagnetic hair. Even a glitch, it could also cause the device to fall into the sun, triggers massive solar spots, burn every electronic device on Earth. In the face of these amazing ideas, the most stable megastructures we can build, maybe it's the pyramid of the index finger. In this imaginative vision of space exploration, we might even consider using Kaplan-3 thrusters as a means of transportation. Head to the vicinity of the black hole to start new construction. In such an extreme environment, build a mega structure, especially with black holes as energy sources. It sounds crazy and dangerous. Physicist Roger Pombos proposed a ways to use black holes as energy sources, and Pombo's process. The process involves a spinning black hole. The event world is called ergosphere is surrounded by. This region warps the spacetime around the black hole. But in theory, it is possible to leave. Penrose suggested, launch a 2-stage rocket into this area. And part of it pushes through and falls into practice. And another part is accelerated by the energy generated by the black hole's rotation. To build a generator, we need to establish the stations near the black hole. Each station is about 12 kilometers long. A site glows. Another station catches these lights. Generate powerful relay light. This way we can extract energy from a black hole, extracting energy to support our colonial development. However, in order to avoid energy leakage, we may need to use scutoff, the proposed method. And with 2 curved mirrors, the black hole is surrounded by a quarter. The light in this light cage will continue to accelerate. Then the specular reflection accelerates again. But this process sounds simple only in theory. In actual operation, unpredictable quantum effects near black holes. It may turn our giant generator into a giant bomb. If we can't control photons, accelerated chain reaction, this structure could explode with the force of a supernova, destroy everything. Finally, if we move to a safer giant, the idea of structure, then we can consider building on the moon. Build a giant inflatable colony. This structure can be up to 11,000 kilometers in length. The use of durable materials and powerful pump to maintain the structure, even in the event of a crash or leak. Use tape, etc. Simple maintenance methods can be repaired. Such a colony could become a phase for a harmless and practical space habitat. Now, as challenging as these ideas may sound, but they showed human, unlimited imagination for space exploration and habitation. From theory to practice, we still have many technical challenges to overcome, but that's what keeps us going.